Okay, good morning, third graders. So we've been working on measurement and time lately, but today we are going to determine the solutions to problems involving addition and subtracting of time intervals in minutes using the SET model. And we're also going to be focusing on determining the solutions to problems involving addition and subtraction of time intervals in minutes using the SET model. So before we get started, I want to just review a few things so we don't forget important things that we don't forget. Just like base 10, with time we regroup in base 60. I know we've been working on everything with base 10, we use base 10 for everything, but it's really important that you remember that base 60 is what we use for time, whether that be in seconds to minutes and then minutes to hours. So 60 seconds equals 1 minute, and 60 minutes equals 1 complete hour. So let's get started on our SET model first. It's going to be, well, let's read the question first. Anna's service shift starts at 4:30 p.m. She leaves work at 8:45 p.m. How much time will it be until Anna gets off work? So we're going to use a time tracker to help us find how much time it will be until Anna gets off work. So we're going to label this column hours, this column minutes, and I'm going to write my starting time so I know what time Anna went into work. So the hours is 4, and then the minutes 30. So it's really important that we jump to the next hour. So it'll be 5, and that'll get us to 5 o'clock, and that's adding 30 minutes to 4:30. And then now we can just jump a whole hour to 6, which is 60 minutes. We'll jump another whole hour to get to 7 o'clock. We'll jump another whole hour to get to 8 o'clock. And so now we're going to jump to 30 minutes so we can hit half hour, which will be 8:30. And if we look, we just have to get to 8:45 because that's what time Anna gets off work. So 8:30. And now we're going to add 15 minutes to get to 8:45. So now we're going to add up all of the minutes so we can see how long Anna's server shift was. So we'll break it apart if it makes it a little bit easier. 30 and 30 will make, well actually, no, we won't do that. We'll do 30 plus 60, and we know that 0 plus 0 is 0, and 3 plus 6 is 90. So we already took care of that, 30 and that's 60. We're going to add another 60. And another 60. And we're just following our time tracker here. Oops. I messed up. Teachers mess up too. But I caught myself, so we'll continue. So 0, 9 plus 6, 10, 11, 12, 13, 14, 15. So, wait, no, I didn't mess up. 5 plus 6 is 11. We'll carry it, we'll take our 1 over there. We'll add a 30. And then plus our last 15. So Anna's server shift was 255 minutes long, and our tool that we used to find the minutes was addition. Now, to find how many hours, we're going to do our tool. We're going to use our tool subtraction. And we'll just do it on this side. And just like we've been working on multi-step problems, this is kind of a multi-step problem too, because we're finding how many minutes Anna was in during her shift, and then now we're just going to convert it into hours and minutes to see how long she was in there. So we have 255 minutes that we counted all together. So now we are going to subtract 30 minutes, and that takes care of this 30. We're going to subtract another 60. We're just going down the time tracker again. And we don't have enough tens in the tens column, so we're going to have to borrow from the hundreds. That takes care of that 60. So now we're going to do another minus 60. Minus, so we're going to take care of another 60. Minus 30, and then they're 15. So it will take 4 hours and 15 minutes. So Anna isn't at work for 4 hours and 15 minutes long. So now we're going to find out how much time will it be until Anna gets off work using our linear model. So another thing to remember during time is that in the analog clock, we regroup in hours by 12. So we do have 24 hours in a day, but in a clock, we regroup it by 12. So this is going to be, we'll just label this our AM. And then at this 12, it'll hit our PM. And then, is there? If not, I can just use it.
See if this will work. I don't know if it'll work.
Okay. Yeah, it works a little bit better. So we are going to start at 4:30 p.m. So here's our 4, and then here's our 4:30, which is the minute. So the minute is in 30, so it's going to go, we're going to go from 4, we're going to start at 4:30. Now we're going to jump to the next hour, which will be 30 minutes, and it'll hit us to 5 o'clock. We're going to jump to the next full hour, which is going to be 6 o'clock, and we're going to add 60 minutes, since there's 60 minutes in an hour. Then we're going to jump to the next whole hour, which is another 60 minutes. We're going to jump to the next whole hour, which is 8 o'clock. And we're going to look at our problem again to see what time Anna's left work, and that's 8:45, so we're going to jump to the next half hour, which is 30 minutes. And just one small jump, 15 minutes to hit 8:45. So, like I said, it's really important to remember with time, we regroup at 60, just like we regroup everything else for base 10, but it's in time it's 60. And guys, today you just worked on using time, using the set model and a linear model.